wa rahmatullahi wa barakatuh. I believe you have practiced a lot about the mole, concept of mole. In my previous class, I gave a concept about the empirical formula and molecular formula and percent composition. The differences between empirical formula and molecular formula, and we showed the percent composition. And I gave homework. Now, my dear students, today I would like to show the process to determine the molecular formula and empirical formula from the percent composition. In my last class, I showed you how to distinguish between empirical formula and molecular formula and the process of determining percent composition. And today it will be reverse. Today it will be reverse. Percent composition to empirical formula and molecular formula. Let's have a look the example so that it can make you clear. This is glucose, C6H12O6. This is the formula of glucose, which is the most important carbohydrate for our body. We're taking this as food to be good. We're taking it as food, glucose. Glucose, if you take the common 6, then it will be empirical formula. So in our previous class, we showed this molecular formula and empirical formula. Molecular formula and empirical formula. And in our previous class, we determined the percent composition of carbon, hydrogen, oxygen of glucose. That time we got the amount of carbon, you know, 40%. Hydrogen, 6.67%. And oxygen, 53.33%. So my dear, full care. The molecular formula of glucose, C6H12O6. Empirical formula of glucose, CH2O. And the percent composition of this compound, carbon 40%, hydrogen 6.67%, and oxygen 53.33%. And today I'll go to the reverse way. I want to go to percent composition to the empirical formula. The percent composition to empirical formula. Have you understood? The percent composition to empirical formula and also molecular formula. So it may come in your exam. How? A compound or an organic compound N inorganic compound or in an organic compound, the percent composition of carbon is 40%, hydrogen 6.67%, and oxygen may be mentioned or not. Then you have to determine by adding the percentage of carbon and hydrogen and subtract from 100. Then you will get the rest of the elements percent composition. It means oxygen. When we'll mention organic compound, carbon must, otherwise your calculation will be dust like the rust. So my dear, full care. So this is a process for class 10 level, SSC level chemistry. Please be careful. This is advanced level. So my dear students, it may come in your exam in an organic compound, the percent composition of carbon 40%, hydrogen 6.67%, and oxygen 53.33%. Determine the empirical formula. So you can write down the question. In an organic compound, the percent composition of carbon 40%, hydrogen 6.67%, and oxygen 53.33%. Determine the empirical formula. And also, next part will be added in such a way, if the vapor density of this compound 90, vapor density is 90, vapor density is 90, or molecular mass double of vapor density 180. So my dear, if it is given, if the vapor density 90, which will be double for molecular mass. So you should recite and memorize. Molecular mass is the double of vapor density. According to the old syllabus, that time it was given. Sometimes it may come in our exam because copy paste. So my dear, vapor density 90, so molecular mass will be double of vapor density. It will be 180. So in an organic compound, the percent composition of carbon 40, hydrogen 6.67%, and oxygen 53.33%. Determine the empirical formula. And if the molecular mass is 180, please determine the molecular formula. So my dear, it's an easiest way. I believe you have understood. Let's see the next part. And now you have to write the given. Given part. Given. How can we solve given? What's given here? Carbon will be 40%. Hydrogen 6.67%. Oxygen will be 53.33%. The first step to determine the mole number. You have to divide this percentage by their atomic mass or mole fraction. It will be mole number or mole fraction. Just an example, 12 gram carbon. For carbon, 12 gram. 12 gram equal 1 mole. 12 gram equal 1 mole. So 1 gram equal 1 by 12 mole. So when it will be 40%, it means 40 gram will be 1 into 40 divided 12. So result will be 3.33%. So this is the tricks and technique to determine the mole fraction or mole number. Clear? So 40% carbon, it means 3.33 mole number. So first step, we have to determine the mole fraction. What is the technique? What is the technique? By dividing the atomic mass of the respective element, you can get this. So in our textbook, there is a given short form. So we can see the shortcut. Step 1, my dear, step 1. You can see the shortcut. Step 1. Step 1, mole fraction or mole number. 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 So at first carbon, percentage divided its atomic mass, which is 3.33, the mole fraction or mole number. And already I have showed this, the process, how you can determine the mole fraction. And this is the shortcut so that it will save you time. There is no crime. Let's see. And now hydrogen, the mole fraction or mole number of hydrogen here is given 6.67. So atomic mass 1, number 1 hydrogen. So it will be 6.67%. Okay. Now the percentage of oxygen will be, you can see that, my dear. Is it clear? Oxygen will be, 53.33%. The mass of oxygen, atomic mass of oxygen will be 16. So result will be, you should use your calculator, 33. So here no need to use percentage. This is mole number. Sorry, my dear, I'm extremely sorry. Okay, so you have got the mole number or mole fraction for carbon 3.33, for hydrogen 6.67, and for oxygen 3.33. Is it clear? Yes? Thank you. You are genius. You are awesome. You have understood everything. Thank you very much. Now, my dear students, this is a fraction. Now we want to get the full number. Okay, about the fraction, mole fraction, we want to get a mole number. What is the process? The second process. You have to divide, you have to take the smallest part of this result. Among 3 carbon, hydrogen, oxygen, you have got the smallest one, 3.33. See, if you want the ratio of the atoms in a compound, so you have to determine the full number, not fraction number. So step 2 will be, please divide the result with the smallest one, smallest division. So step 2, my dear, step 2 will be, step 2 will be, what's that? Please. What will happen? Step 2. To get the ratio of the atoms of the compound, it means empirical formula, you have to divide by the smallest division with the result which is obtained from the percent composition. Let's see. It will be better for you and you will understand my view. So carbon, shortly we can write here, carbon will be the result 3.33, and the smallest division, you can write at first carbon, hydrogen 6.67, and oxygen will be 3.33. This is the result. So among them, which one is the smallest one? So in both cases, for carbon and hydrogen, in both cases same. So we should divide by 3.33. So 3.33, and the result will be 1. And when 6.67 will be divided by 3.33, it will be closest to the 2, and oxygen will be same. So it will be 1. This is the ratio. This is the number ratio of the respective elements of this compound and non-compound, the organic compound, which will be determined within short time. Let's see the next step. Next step will be just we have to put the value or mole number beside the symbol of the respective elements. What will happen? Let's see. So my dear, full care. No. Yes, step 2. And now step 3. So this is step 3. I believe you will understand. Step 3. Is it clear, this color? Okay. Now step 3. My dear, empirical formula. Therefore, empirical EF, empirical formula, and this compound will be just the symbol CH-O. So carbon will be 1. This is 1. You have got 1, and hydrogen 2, and oxygen 1. So result will be CH2. It is known to you, isn't it? Chena chena lage tobu chena. Can you imagine that? Chena chena lage. It's known to you. So my dear, CH2O, you can think, you can work, you can make your brain functional. What's going to happen? What's going to happen, my dear? What will happen? What is going to? So my dear, really, this is known to everybody, CH2O. So after that, it will be clear like a transparent water, and you will be better, and you can play guitar. Let's see, my dear. So CH2O is the empirical formula of the respective compound. And now we have to determine the molecular formula by using the empirical formula. We have to determine the molecular formula by using the empirical formula. Let's go. Molecular formula. like this, molecular formula, like this. Molecular formula. You know, my dear, this is the formula of water. This is the formula of water, H2O, hydrogen oxide, isn't it? Now, molecular formula, the mass of hydrogen 2 and the mass of oxygen 16, it will be 18. So you can understand easily, molecular formula equal molecular mass. So you should cast molecular formula equal molecular mass. This is the molecular formula of water and this is molecular mass. So from the discussion, we can take the decision molecular formula is equal to the molecular mass. Molecular formula is equal to the molecular mass. We know that very well from class 9, from class 8 and from my discussion. So we can take the action. If you want to determine the molecular formula, you don't know how many atoms are present and how many moles of atoms are present in this compound. So we have to multiply with an unknown number. You don't know, but we can determine by using molecular mass to get the molecular formula by using the molecular mass and also empirical formula. So let's see, you can imagine the molecular formula will be for this compound CH2O, this is all to the power x. You don't know what is the exact number. What is the exact number? What is the value of x? You don't know. But we can determine how. Hey man, can you imagine that? Now you have thought this is molecular formula and also in your question paper is given the molecular mass. Probably you can see, yes, 180 molecular mass. In your question paper it's given what is the vapor density. By using the molecular mass, we can determine the molecular formula. By using molecular formula is equal to the molecular mass according to condition we know. So shortly we can write here we know. Shortly we can write here we know. Molecular formula is equal to the molecular mass. What do you mean by molecular mass? Molecular formula. So what is the molecular formula? CH2O and this is X. Imagine that. We say is equal to the 180. So my dear, now where's the TOD? Just you have to put the value of atomic mass of carbon 12 plus hydrogen 1 into 2, it will be 2 and oxygen 16. So it will be X 180. So my dear, full care, result will be 30x is equal to the 180. You should write here or and this is or, and now you can write here x equal 6. This is the ratio. This is the ratio of the atoms of this compound. So if you put a value of x here, then exact formula will be found. My dear, by putting the value x here, you can get the molecular formula. Really fantastic. Amazing matter to get the molecular formula from the percent composition. Just like the reverse process. At first, we have learned the process to determine the molecular mass from the atomic mass and the percent composition. And today, we have learned how can we determine the molecular formula from the percent composition. Just reverse. So my dear, full care. So molecular formula, you should put the value x here, then you will get the exact number of atoms which are present in this compound by putting the value 6. So it will be C6, H12, O6. This is glucose. Is it clear? Oh my God. Yes, this is glucose. This is known. So a few minutes ago, I sang a song, Chena Chena Lage, Tobuo Chena. So my dear, that's why. So listen carefully, observe carefully. We are trying best, to be honest, to make your result better and best. So you have to practice more and more. You are the students of class 10. You have not enough time to waste. You have not enough time. If you do this, it will be crime. So please concentrate. Please concentrate. It's mandatory for everybody. For everybody. And also, I believe your mom and daddy, everybody will take care whether you are sitting to read or not. They will take care. If you sit to practice, definitely it will be good, it will be better for your future. Please change your gesture at this moment. My dear students, I believe you have understood the process, how to determine the empirical formula and molecular formula from the percent composition. This is water, and please, you have to try by sitting at your home to determine the percent composition and molecular mass by using atomic mass. Then again, you should try to come back reversely by using its percent composition and molecular mass. You have to determine its empirical formula and molecular formula. Please, this is the criteria. Yourself. The example will be sodium carbonate. This is your homework. This is your homework. Please. Homework is W. What's that? Percent composition. Percent composition, you should try to determine the percent composition and molecular mass. And again, from the percent composition and molecular mass, you have to come to the molecular formula and empirical formula. I believe you will do this. This is your duty. And when you will do this, it will be beauty. And it's called sincerity. And also, in such a way, we have to show the creativity. So, my dear, please, you should care. And also, you should share. Inshallah, will care. And it will be fair. Alhamdulillah. We can see the first step so that you can understand. The question was, in an organic compound, the percent composition of carbon, hydrogen, oxygen, 40%, 6.67%, 53.33%. If the vapor density 99 of this compound, if the vapor density is 90 or the molecular mass is 180, determine the empirical formula and molecular formula. Determine the empirical formula and molecular formula. So you can see the question here is given, and now sometimes it may come in such a way. Please be careful to understand. A is an organic compound. Organic compound. Organic compound where hydrogen 6.67%, oxygen 53.33%. 53.33%. Determine its empirical formula. Imagine that, empirical formula. Just determine its empirical formula. Have you followed this? Have you watched carefully? If you try to sum, please add what is the addition of hydrogen and oxygen. 53.33 plus 6.67 is equal to the 60%. This is not complete 100%. So someone is present in this compound. This is the hidden things. And you can fall in trouble. Someone is fell in trouble. Clear, my dear? This is the reality. What will happen, my dear? Just you can think this is organic compound. This is organic compound. So carbon is must. In organic compound, carbon must. Carbon must. I believe you have understood in such a way. Then you have to mention here must. This is not 100%. Must someone is present due to organic. So it will be 100 minus 6.67 plus 53.3. So it will be 40%. So in such a way, sometimes you have to apply tricks. So I believe you have understood properly and clearly, and you should try yourself. So stay home, stay safe. Thank you very much. Assalamu alaikum wa rahmatullah.